There are a couple of tools you need on your local PC for this course. Since we need to containerize our application, it's necessary to install Docker, a tool that builds and delivers software in packages called containers. Visit the website on the screen and select the appropriate OS of your laptop to get started. There you will find detailed steps for deploying Docker on your operating system. As a note for Windows OS users, you will need to also install Windows Subsystem for Linux version 2 from this website. This will enable your laptop to run both Linux and Windows containers, although not simultaneously. You would also need to install Git for version control of the source code, Visual Studio Code for development of the application and defining manifests, and finally you need to install Node.js version 14 or 16 LTS. Additionally, you will need to create a profile on Azure Portal as well as Azure DevOps, so visit the site on the screen to sign up. It's assumed that you have some experience with Azure Portal, Azure DevOps, kubectl commands, and Azure CLI. Most of the commands would be provided in this course, but our main focus is defining manifest files and deploying workloads to Azure Kubernetes service. There are situations where we would run some commands in Visual Studio Code and other times in Azure CLI. As you follow along, you will be informed about using the same Azure CLI session to deploy Azure resources at once. Otherwise, you would have to define some environment variables again. Finally, it's important that you do use a separate Azure profile from your work account to first learn and experiment what you see in this course. There will be a need to create identities or service principals in Azure Active Directory and assign certain roles. This is not advisable in your production subscription. For a long time, software applications were mainly developed as monolith, where all the functionalities of the application were tightly coupled in a single code base. For example, an e-commerce application would consist of functions like user management for sign-up, signing, and password recovery, catalog management for storing and displaying available items in stock, payments function for checkout and payment solutions, orders management for displaying customers' orders, cancel order functionality, among others. All this made a monolithic application quite large and difficult to scale. Since monoliths are tightly coupled, a failure in one of the functions could make the application crash, causing a downtime of your web application. However, in the past couple of years, microservices are increasingly popular in software development. Microservices are loosely coupled, small and independent software applications that are deployed separately from each other, loosely depend on each other, and each persists their own data in their database as part of a broader software application. Using our e-commerce application example earlier, a microservices architecture approach would be to design a microservice for user management, another microservice for catalog management, one for orders, and another for payment solutions. Each of these 4 microservices would have its own database to persist data. This way, your microservices are scalable to meet the demands of the business and reliable because a failure of one of the microservices does not necessarily affect the availability of other microservices. And one more thing, due to the small size of your microservice application, it's much easier and faster to run and test your microservices in isolation, not relying on input from another microservice. Now you may wonder how microservices fit into Kubernetes infrastructure. Since microservices are small, independent applications that fulfill a specific business or customer function which you can scale out or in, manage and update independently, it gets to a point where managing deployment and scalability of multiple microservices becomes a manual task that you as an IT or software engineer would want to run away from. Architecting microservices-based application with Kubernetes accelerates the delivery, scalability, and reliability of your microservice applications. However, before you run your microservice in Kubernetes, you need to containerize the microservice. This involves packaging your service, its dependencies and configurations into a container image. This way, your container image can be deployed and scaled as demand requires in a Kubernetes cluster almost instantaneously without intervention from you as an IT engineer. In this course, we would use Azure Kubernetes Service, which is a managed Kubernetes orchestration software that provides a means to deploy, manage, and scale multiple containers. It can automatically discover services you deploy, allocate appropriate compute resources, and expose your services securely to the internet through a load balancer. To design a software application following the microservice architecture requires a different approach from when building monoliths. Since microservices are small, independently deployable applications that own and possess their data, you have to consider how your microservice would communicate with each other, store their data, and be deployed via CI/CD pipelines. A basic principle of microservices is that each service owns and manages its data. As a result, no two services should share a database, and if one service needs data from another service, that can be accessed over the API of the service or some other means like an event bus or message queue where microservices publish or subscribe to events. Following this approach ensures that if one service or database is down, other services are not affected and would continue to serve your customers. For example, the cancel order function from others' microservice of an e-commerce application may be having high network latency, but users can still log into your app and buy items as there are different microservices handling those functions. See how loosely coupled your application is when following microservices architecture? Another benefit to this is you can change your data schema for a particular microservice without affecting availability of other microservices. Designing microservices requires a domain-driven design approach where each service has a bounded context. That is a boundary around a set of functional features. For example, functions related to user management such as account creation and modification, login and password recovery are defined in a single microservice. This way, all the defined functions don't exchange data with each other via APIs and all have access to the same database. Separating some of these functionalities would seem difficult to maintain and require additional services to ensure data integrity across the databases being accessed. Another step to consider while designing your microservices is how communication would occur among the services. Currently, there are two common types of communication, synchronous and asynchronous. With the synchronous approach, communication occurs in real time over HTTP by directly calling an API of another microservice for fetching data. While with the asynchronous approach, communication occurs via an event-driven service where a microservice publishes an event because of an action, and then interested services that subscribe to these events receive those events and act on it based on the defined functions. For example, create or update a record. Using an asynchronous approach in your microservices design provides benefits such as high availability and further decoupling of your application, as there isn't a need for either microservices to understand the underlying design or functionalities of each other. It just expects a certain type of event to perform its function, then waits for another similar event. You can also scale out the microservices to handle events during peak periods, and if a subscribed microservice is temporarily unavailable, the events will remain in the message queue till the microservice is restored. Then all queued messages get processed. This way, you don't lose entries that occur during a downtime of a microservice. Synchronous communication, on the other hand, creates tight coupling, which defeats the purpose of microservices architecture. In this case, if a service, for example, service A, requires information from service B over HTTP, but service B is unavailable at that moment, service A will not respond back to your customer or may even crash if proper error handling is not defined. These availability concerns can also affect the ability to replicate a subset of data to a secondary service that needs it during a post-method operation. So it's important that when you are considering to adopt microservice architecture for your software application, you identify how you will manage databases for each microservice, communication approach among microservices, and automated deployments. Also, you must define your microservices using a bounded context approach, as this will help you avoid performance issues from network and database operations. The sample application we would be using throughout this course is a typical social media application where users can create posts and comments on a post. Users can access the home page without having to sign in. However, a user must be authenticated to create or modify posts and comments. By merely describing what the social media application would do, you can imagine that with a microservice architecture approach, we should have at least 3 microservices for this application. At the top, we have the user's microservice, which would handle authentication of users for every create or update action on a post and comment, as well as process user registration and sign-out functions. User data is stored in a document DB, Mongo database, and other microservices except the UI or front-end are each connected to a separate database. For this application design, no user data is published to the event bus. Authentication occurs via a JSON Web Token, which is signed during a registration or login activity. This token is stored at the client side and would be verified by other microservices that receive HTTP requests to create or update a record. For example, Post microservice would verify the JSON Web Token sent with the request from the client using a JWT secret we would define in the cluster. If the user is not authenticated while trying to create a post or comment, the action fails. The post microservice has functions for creation and modification of a post by the user who created it. There is also a function to publish a post creation event to the event bus so that comments microservice will have the post ID in its database and link future comments to it. Furthermore, Post Hub microservice, which is also a subscriber for post-created events, would save a few details like post ID, user ID, post and comment details to its database. The UI only displays all the posts and comments from Post Hub microservice. This way, if post or comments microservice is temporarily unavailable, the only functions to be affected would be users' ability to create a post or comment, but they can see all posts with associated comments created prior to the downtime. Just as with post, when a comment is created, an event is published by comments microservice to the event bus, and post microservice would update its record with only the comment ID, while post hub would update its record with the comment ID and contents. Modifications are only allowed by microservices that own the data, effectively being the source of truth for related record. We would use NAT streaming server to enable event-based communication among the microservices that publish or subscribe to events. There are a couple of other event bus platforms you can use like Azure Service Bus, RabbitMQ, etc. NATs would be deployed for this application, and we will explore the manifest file for these as well as for the Mongo database containers for each microservice. To expose our application over the internet, we need to deploy an ingress controller as well as an ingress resource. An ingress controller is a special load balancer for Kubernetes cluster, which applies the traffic rules defined in an ingress. It exposes your application from inside the cluster to become reachable outside the cluster. For this course, we would use Azure Application Gateway and enable the Application Gateway Ingress Controller, which integrates with Azure Kubernetes Service. So this architecture represents how our microservices will communicate with each other and be reached over the internet from the Kubernetes cluster. 5 microservices will be deployed along with some database containers and an event streaming service for services to publish or subscribe to events. A Docker file is simply a text file with a series of defined commands that execute in succession to build a container image. So with Docker, we are going to create a series of containers for our microservices, which would act as an isolated computing environment. In other words, each container would have everything required to start and run a microservice. Once containerized, if we need to run multiple instances of a particular microservice, possibly due to expected high traffic to the application, then we can create replicas of the same container image to handle more requests. And the good part of using an orchestrator like Kubernetes to manage your containers is the ability to automatically load balance ingress traffic across multiple ports of the same container image. To begin, please make sure you've cloned the repo from GitHub following the steps in an earlier video. Open your code using Visual Studio Code and change the branch to match this video. To confirm or change branch, go to the lower left corner of your Visual Studio Code and click on the branch menu, then select the appropriate branch for the video you're watching. At the left Explorer section, right-click UI folder and click New File. We'll create a Docker file and it usually starts with a capital D, then enter. Notice that we have a Docker ignore file already defined. Just as a .gitignore file, the Docker ignore file contains a list of files and directories that you want ignored when Docker is building an image. For example, the node models directory, which Docker would eventually create in the container if you add the necessary command to install npm packages. Next, I'll be checking my extensions list in Visual Studio Code to be sure that the Docker extension is installed. On the left activity bar, click Extensions and search for Docker. Once the result is listed, click Docker and make sure that Docker extension is installed. If it's not, click the Install button and wait for the installation to be completed. There is a format when defining a Docker file, and it usually starts with an instruction written in uppercase followed by the arguments. I'll simply paste a sample command, and you can see here we have the from base image, which would use a Docker image from Docker Hub. The work directory represents the root directory name of your application in the container. The copy files command is used for copying over files from your app's local directory to the container image. Run command is used to execute actions like npm install, delete files, install Linux packages, etc. The cmd, which is used to define the default command, can be used to start up your container. The commands would differ depending on the type of application you plan to build. The commands for a Next.js application are quite different from a React application you wish to serve via Nginx, and you can explore more on these based on your use case. There are really lots of community information out there to help you. Now, back in my Docker file, I've deleted the content from the previous video. I'll paste the commands I've defined for this course and explain the contents. Scrolling through the Docker file instructions, you would notice that this is a multi-stage Docker file, and we use multi-stage builds when we care much about the size of our container image. Each instruction in this Docker file adds additional layers which you would see when building an image. But at the end, you might have such a large container image with size of hundreds of megabytes. Using a multi-stage approach would help us as we add an instruction to copy only the needed artifacts to the production image. From the top, we have from Node 16 Alpine as deps, which stands for dependencies. Alpine is a lightweight Linux image with a size of approximately 5 megabytes, making it quite small. But this image with Alpine tag means we want to build our application in a Linux image that has Node.js installed. To know the image to use and the appropriate tags, you can visit your Docker profile and search for the image. There you would find the status of the image, when it was last pushed, if it is maintained, and the size of the image. The run instruction is used to execute commands like installation of packages, running npm commands. So in line 3, we want to install a critical Linux package in the node image for our build process. In line 4, we have the work directory set to /app. This command sets the working directory within the node image to the defined path, so that subsequent instructions like copy files or run commands will be from the work directory. The copy instruction will copy package.json and package.log.json files from the system directory to the work directory, which is /app, and then run npm CI. Since this is a multi-stage Docker file, as we want to optimize the size of the final image, we have a second stage defined as builder, where we copy our node modules folder that was installed in the first stage, copy our source code from the local directory to the work directory, and then run npm build. For the final stage, we have similar instructions like run from node alpine, set work directory to app, and we have an environment variable node env set as production. I added an instruction to install coil just in case I need to troubleshoot network issues in the final image when it's deployed. This is only temporary and can be removed if it's not needed in your image. One of the best practices for running containers is to disable root accounts. This helps reduce vulnerability of your image and prevents any process or persons from hijacking the running container to execute malicious code. This is why we create a user group and add a user Next.js to this image. This will cause the container to run with Next.js user only, and if, for example, you try to install a package in the running container, you will get permission denied notification. Recall that multi-stage helps with reducing image size, so now we have some copy instructions to copy only production files from the previous stage tagged as builder to the production image tagged as runner. These are the files needed to run our Next.js application, like the public folder, package.json, node modules, and next folder. After that, set the user as Next.js, expose port 3000 for our container, with an option to always change the port in the future using environment variable, and run npm start to serve a front-end application. And that's it. Defining a Docker file gets easy with time, and you can even have a template for similar application which is what we would eventually do. All of our backend microservices would have similar definitions, and all we have to do is to copy and paste the content in the Docker file of other services, then modify a few things. For your exercise, try to create a Docker file for other microservices, then define the commands in the Docker file of each backend microservice. Note that the backend is not a Next.js, but Node.js application. So there might be a couple of instructions you want to remove, but still maintain a multi-stage approach. I hope you were able to define the Dockerfile commands for the other microservices: post, comments, post-up, and users. The great thing about defining Dockerfile is there is not just one way to do it. You can define your Dockerfile as a single stage, multi-stage, or even omit some parts. So I'm quite sure your Dockerfile may not completely look like mine, but let's review the commands for our backend microservices. I'll start by reviewing the template for the user's microservice, then we can replicate the file in other microservices. In your VS Code, at the left side of the screen where you have the Explorer section, right-click the users folder and let's create a new Docker file. Remember to start with a capital D. I'll simply paste my predefined code and walk us through each of the instructions. You would notice that I have just 2 stages in this file. Reason is, multi-stage Docker files sometimes takes longer to run, and to reduce that, you can eliminate or merge stages. So let's review the commands from the top. We start with the from base image, and again, we use node alpine docker image. Set the directory to /app and copy our package files from the host system to the Docker image. Then run npm CI, which is equivalent to npm install, but the only difference is this is more suited for automated workflows. The next command copies all the files we excluded in .docker-ignore, then builds the source code by running npm build. In the last stage, which would be our running image, we also have similar instructions like from alpine node, set work directory to /app, and we have an environment variable node_env set as production. The copy instruction would copy the distribution folder from the previous stage as well as the package files, then run npm install for only production dependencies using the omit dev argument. As a best practice, you should run your container with a non-root user. So we set node as the user for this image and expose the port 3000 with an option to change the port using the environment variable parameter. Finally, we set the entry point as npm start, which runs our container image. And that's it. Now that we have a template for one of our backend microservices and the instructions would remain the same across the backend services, let's simply copy the Docker files into the other microservices. In the users folder, right-click Docker file and select copy. Let's start from the comments to paste the Docker file in the folder. So right-click comments folder and then select the paste option. Let's also do this for post-up. Right-click post-up and paste the Docker file. And lastly, for our post microservice, right-click the post folder and then select paste. Assuming you work with a team of developers and all projects are coded in the same programming language, you can simply define a template like this, test it locally, and then share with the team to use for other similar microservices, saving the team some time from repetitive work. Let's create a Docker image for at least one of our microservices to be sure it will build successfully when we automate with CI/CD pipelines. Before we start creating images, let's check this out. In a typical setting, several development teams of 2 or more developers would work on microservices for an application. Team A could be working on authentication or user management microservice, Team B on payments and orders microservices, C on posts and comments, and so on. That way, it's easier to test the microservices locally since you're only focused on 1 or 2 services. And recall that microservices must run independently and own their data, allowing you to test if your functions are correctly defined and to fix bugs immediately. Well, in some cases, this might be missing, and maybe a single developer would develop multiple microservices. In that case, you might need a way to locally test your containers, and there are a couple of tools you can use, some of which are the Docker Compose tool for defining and running multi-container images. You make references to the Docker file in each microservice and then run certain commands to start or stop the containers. There is also Scaffold, which is an open source tool that allows you to develop and test on the local Kubernetes cluster. The difference between these two tools is that Scaffold runs your microservices in the local Kubernetes setup, allowing you to sync file changes and almost immediately test these changes in your local cluster. You can read up the docs and try it out. In this course, we would be focusing on deploying microservices in Azure Kubernetes cluster, so we won't be deploying local Kubernetes cluster to test our microservices. Now let's create an image for our UI or front-end service to be sure it builds successfully. Back in the VS Code, let's open a terminal to run the docker build command. If your terminal isn't open, you can go to the menu bar at the top, click View, and then click on Terminal. If you want to know the commands available in Docker, you can type docker-help, and you will see several commands, for example, to create, pull, and manage your images or containers. To build the UI image, let's navigate to our UI directory first in the terminal by running cd UI. This changes directory to UI, and then let's run the docker command. So you type docker build -t, the name of the container image and the version. Then don't forget to add dot after typing the commands. If you get an error indicating that the Docker daemon is not running, ensure that your Docker desktop application is running on your system. You can go to Start menu for Windows users, search Docker desktop, and open it to run Docker. Wait for Docker to start, then run the docker build command again in your terminal. This command executes the instructions defined in the Docker file for UI microservice and applies the tag UI version 1.0 to the resulting image. The -t parameter is for providing a name tag to identify the image. Later in this course, you would see why it's important to specify a tag for your image. The dot at the end of the command represents the path to the Docker file. Since we are running this command in the root directory of the Docker file, we specify dot. Outside of the root directory, you have to define the full path. Reviewing the logs for our docker build command, our image was built successfully, and you can see the various executed instructions as defined in the Docker file. For example, we have the set work directory to app, copy the package JSON as well as the source code, and in the last stage, copy all the required Next.js files from the previous stage build. Let's check out the size of our Docker image in Docker Desktop. You can run this command, docker images, and let's grep for UI. Voila! The result is the list of image tagged as UI matching the exact search string. Now I see my image was built and the image size is about 339 megabytes. Let's also test building one of the backend microservices quickly. Let's try users. Change the directory to users root folder by running cd /users. Then let's run the docker build command again. Docker build users version 1.0 and dot. Oh, I forgot to add -t parameter. So docker build -t users version 1.0 dot. Voila! The image is created successfully. Let's run the docker image command again to check out the size. So docker images, grab users -w. We have about 215 megabytes for our users microservice. So we just ran this docker build command for the UI and users service to be sure that it would also successfully build when we use automation pipeline. You can attempt to build images for the rest of the backend microservices like post, comments, and post-up, just to be sure that your Docker files are accurately defined. Let's run locally our UI and users microservices to be sure a new container starts up successfully using the images we built earlier. Please note there might be some errors when we start up the containers, and that's due to some conditional checks in the code that requires a couple of environment variables are defined or else the app fails to start. Let's start with our users microservice. To run the users microservice, I'll change directory to users by running cd /users. Now let's run a container for our users microservice. To do that, you type docker run -it -rm -p3000 :3000 and then the name of the image and the tag. This command will start a new container using the user's image in an interactive mode, that is the IT argument, and remove the container once we close the terminal or end the session, that is the RM argument. -p option is used to bind the port 3000 of the container on the right side to the TCP port 3000 of the host machine, that's on the left side. Remember, in our Docker file, we defined a command to expose port 3000 of the image. We can use another port, say port 80 of the host system, bound to port 3000 of the container image, as long as port 80 is available and not used by another service. Let's press enter to run this command. Awesome. The user's container started but failed, and that's a good thing. The error you see here is because it checks that the JWT key environment variable is defined for the service to run successfully. Without this check, you could start up your container in a prod environment and have requests failing in the microservice due to missing parameters without knowing. Let's create a container for our UI app. To do that, I'll simply change directory back to UI by running cd /UI. Let's run the same docker run command as earlier, but replace the image name and tag. So docker run -it -rm -p3000 :3000, the name of the image and the tag. Enter. That's awesome. Our UI microservice started successfully. If you would like to browse the UI microservice, simply go to your browser and enter localhost colon 3000. In the terminal, you would see an error once you're able to browse it, which shows that the conditional checks is working. However, these errors will not occur when we start the app with required environment variables in the Kubernetes cluster. Your applications may not necessarily have checks like those defined here. This is just an additional check for this particular application to ensure that the Kubernetes environment has the necessary parameters defined before deploying the microservices. Now that I am sure my images for UI and users microservices start up successfully, I can close this session for the UI to exit the container and free up my port 3000. To do that, simply press Ctrl+C to end the session. To confirm if the container is closed, you can run docker ps, and you see that no containers for UI or users are listed. If you had built the images for other microservices after the previous video, go ahead and run them to be sure it starts up successfully. Remember, you have to change the host port and use the appropriate name tag. It's time to define a deployment and service for our front-end microservice. Before that, let me briefly explain a deployment. Recall earlier we built an image and launched it locally as a Docker container. Now, if I desire to run replicas of the same image or improve availability of my application, then I would have to manually run the same command multiple times and specify different ports to start up additional instances. To fix that manual situation, that's why we have Kubernetes, an orchestration tool to manage our containers. And to take advantage of these, we have to define a deployment for the microservice. A deployment provides declarative updates for pods running containers in a cluster. In a deployment, which we would configure soon, you describe the state your application should be in, and the deployment controller in Kubernetes would apply that state to the cluster. You can read up the documentation about deployment via the link displayed on the screen. Back at my terminal, there is an extension that can suggest code snippets of Kubernetes to define your deployment. To install that, on the activity bar at the left side of your Visual Studio Code, click Extensions and search for Kubernetes support. Once you have your results, click Kubernetes support, and if this is not installed in your IDE, click the Install button and wait for the installation to be completed. Now let's define manifest for our UI.yaml. Go to the Explorer view at the top of the activity bar, and then in the project root folder, right-click and click New Folder. We'll create a folder named K8s and a subfolder named prod-manifests. Enter. Now right-click prod manifests folder and select New File. The name of the file would be ui.yaml. Kubernetes manifest files are written in YAML syntax, therefore the file extension should be YAML. In my ui.yaml file, let's type DEP. You should see a couple of code snippets to choose from. I will use the Kubernetes deployment code snippet and define additional parameters. So click Kubernetes deployment. As with all other Kubernetes configuration, a deployment needs an API version. The wrong API version would cause your manifest file to fail to apply desired state to the pods in a cluster. So for this deployment config, we would be using the app/v1 API version. Kind represents the kind of object we want to create, which is a deployment. The metadata field is where we set values to uniquely identify the object we want to create. So here we would modify the metadata.name to UI-env dash. And we'll also add a namespace key, namespace with a value ns post hub -env -. I define a namespace because I want all related microservices for this application to be grouped into one namespace. The env keyword represents environments. For example, to deploy to dev environment, our pipeline, which we would configure later in this course, would have a task to replace env with dev. And for the test environment, env would be replaced with a test. This helps to distinguish between dev and test when troubleshooting or reviewing logs for our microservices. The spec section is where you set values for the desired state of your object. In this case, the deployment object. Let's add a field named replicas and set the value to 1. So create a line after spec, press the tab button, and then type replicas and change the value from 0 to 1. This means the UI would have a single pod running the container image in the cluster. You can increase the value if you'd like, but this is just to show you how to set replicas of your microservice. We have the selector the match labels.app value set to my app. Let's replace that with UI-env. This information is used by the deployment controller to manage all pods that have an app label set to UI-env. So if there is a new desired state to be applied, it understands that it should only apply to apps labeled with this value. The template section is used to define the specs or values each pod should have. For example, each pod should have a labeled key named app and value set to UI-env. So we would replace my app with the UI-env keyword. We also have the pod.spec section, which would have specifications for each pod that will be created or managed in the cluster. There is a container section with the name key. Replace my app with UI-env. So I'll paste the value here. The image value would be the location of our container image to be pulled and deployed in the Kubernetes cluster. Let's use a variable here, and later on where we define a task group for our build pipeline, we would replace the value with the Azure Container Registry URL and image name. Set the image value to, let's copy this and replace it with __ image tag and end it with double underscores. It's advisable to define compute resources your pod would utilize so that the application does not restrict other microservices from running in the cluster. So under resources, you can define limits only, which would make your app start up with whatever value defined as limits, or you can define requests with limits, making the values for requests lower. The kube scheduler would use requests to determine the appropriate node with available resources to accommodate the pod creation, and the kubelet enforces that the container cannot use resources beyond its defined limits. Just below resources, let's create a new line and press tab, then type requests. Let's define the CPU resource to be 250 M. The M represents a quarter of a CPU core. And then let's define memory to be 350 MI. MI represents 350 megabytes. Let's update the limit memory to 900 megabytes. Doesn't have to use up to that, but it's just available for you to use. While the CPU would be 1000, which is equivalent to 1 core. Our UI would be reachable on port 3000, so let's replace this port with 3000. To expose the ports created via deployment, we must create a service. This is an abstract way to expose your application running on a set of ports as a network service. Think of it as a load balancer, but an automatic kind of load balancer where you don't need to define the IP addresses of each port for it to direct traffic to the backend ports. You can simply define a spec.selector.appValue to match the name of the application defined in your deployment object, and the service would always watch and direct traffic to all existing and new ports with that label. You can check out the documentation to learn more about services at the link displayed on the screen. You can define the service object in the same file as the deployment object. To do this, after your deployment config, create a couple of lines and simply type 3 dashes. This indicates a separation between a deployment and service. Press enter, and since I have the Kubernetes support extension installed, I'll simply type service and select the first option, which is service complete. The kind of object is service, just as we defined deployment earlier. API version is v1. Different objects have different API versions with desired specifications. Let's change the metadata.name to UI-service-env. UI-service-env. All right, and this service will expose our UI ports. Let's add the namespace field to the metadata. So create a new line and type namespace, and let's ns post up -env. Replace the spec.selector.appValue to be UI-env, just as we had earlier in the deployment object. Each service must have a spec type, which defaults to cluster IP. So if you choose load balancer and apply this manifest file to your cloud-provided Kubernetes cluster, then your cloud provider will deploy a new load balancer with a new IP address for you. Do this for 10 services, and you have about 10 load balancers with 10 IP addresses deployed. In this course, we would be using an ingress controller to manage and expose services. As a result, we have to choose cluster IP type or remove it, defaulting to cluster IP. Then in our ingress manifest, we would define the service we wish to expose to the internet, making it reachable outside the cluster. So delete load balancer, and you can also delete node port. Let's delete the name of the port, or replace it with UI-env. The port value for this UI service can be 3000, and the target port, which is defined for the port targeted by the service, would be 3000. Recall we have a container port set as 3000, so we would replace this value with 3000. All right, we are done defining the service and deployment config for our UI application. When we apply the manifest to our Kubernetes cluster, the desired state for the ports and service will be created. This way, a new port is automatically created if an existing port crashes and the number of existing replicas do not match the desired state defined in the deployment manifest. As a challenge to you, Attempt to create a deployment and a service for one of the backend microservices, say the user's microservice. There might be a couple of new fields to define, but the overall concept will be similar. I hope you were able to define the manifest for users microservice. If not, we would go through that together and add more fields based on the requirements of our overall application. First, let's create a file in the prod manifest folder named users.yaml. So in the Explorer view, right-click prod manifest, select new file, and type users.yaml. I will simply copy what I have in ui.yaml into users.yaml to save time. So open the UI YAML file, select all using Ctrl A, Ctrl C to copy, and back in my users file, I'll paste the content. Wherever I have the UI keyword, I'll replace it with users keyword. So let's use Ctrl F to find, and then I'll type UI in this field. Click the button beside the search box, and then in the replace box, I'll type users. Oh, that's there already. So click replace all, or you can simply replace the values one by one. I'll click replace all to continue. And then let's close this. Our backend needs to communicate with a database to store and retrieve data. So instead of hard-coding the database value in the application's code, we are going to use env field setting to define environment variables that must be present in the pod. After the containers.image section, create a new line and type env, then a colon. Create a new line, and there we would have dash name, colon, and the name would be Mongo underscore URI. Create a new line, press the tab button, and then we'd have value, which would be MongoDB colon / users dash Mongo dash service colon 27020 / users. Later on in this course, we will define a deployment and service for users Mongo database, which would match this value. We also need a JWT secret defined for the authentication function in users microservice to sign and verify auth tokens. To make this uniform across microservices, we just have to define an environment variable to reference the JWT secret we would configure in the cluster later on in this course. So after the Mongo URI variable, create a new line with a name being JWT underscore key. So go back one step and type dash name JWT key underscore key. It's important that you maintain the uppercase value for the name. Press enter to create a new line, and then press tab and type value from. The value from represents the source for the environment variable's value, which in this case is a secret defined in the cluster. So after value from, create a new line, press tab, and then type secret key ref with a colon. Enter, create a new line, and press the tab, then name with a value JWT secret. And the key would be JWT key. It's important that these values match the secret that will be defined later. The JWT underscore key name is referenced in the application as process.env.jwt underscore key. You can see that by navigating to the users folder, source folder, and then open the index.ts. At line 8, we have a process.env.jwt key. Let's also quickly modify the compute limit to 700 M in our user's YAML file. So scroll down and change the compute limit for our user's microservice to 700. To improve user experience by making sure that requests are routed only to ports that are ready to receive requests and not a failing port, we can define a readiness probe to perform a health check against the container to be sure it's ready to receive traffic. I will define this after resources, so create a new line after limit.cpu. Press enter, go back 2 steps and type readiness probe. Press enter, then type http get with colon, enter. The path would be /API/users/health check. This route is already defined in our users microservice. Create a new line and then type port, which would be 3000 for our application. The scheme would be HTTP. Press enter. Go back 1 step and type initial delay seconds. Set this to 10 seconds. Initial delay seconds represents the number of seconds after the user's container has started before health check probe begins. Let's also create a new line and type period seconds and set this to 10 seconds. Period seconds indicates how often a health check probe should be performed. In this case, it will be every 10 seconds. That's basically all for our users microservice. Now you would notice that each object, whether a service or a deployment, has a very specific namespace defined. There might be a situation whereby the namespace does not already exist in the cluster, and this would cause our manifest to fail to deploy the ports and services as needed. To solve this, I will add an additional instruction at the top of each manifest to create a namespace. You may wonder if these already exist in the cluster and you try to deploy another manifest, won't that delete the existing namespace? Well, the good thing about deploying declaratively to the Kubernetes cluster is if there is no change to a document, then nothing happens in the cluster. So if a change is made to deployment in this manifest, but not to service and soon to be defined namespace, then only deployment changes would be applied while others remain unchanged. At the top of this file, let's create some lines and add 3 dashes document. So click line 1, create new lines, and then let's add the 3 dashes line separator. Back at the top, I'll type namespace and then select the code snippet. Let's replace the metadata.name to reflect the value I plan to use for this project. So I'll just copy the namespace value here and then replace what we have here. I'll also add labels field. So create a new line after the metadata.name, type labels, create a new line with name set as ns_post_env. And that's all. Let's copy these and paste in the UI manifest. So copy and then go to UI manifest, Select the first line, create new lines, and then paste the contents I just copied. Ensure to save both files after making these modifications. As another challenge, now that you know how the manifest for a backend microservice looks like, create Kubernetes manifest for the rest of the backend services, and remember that the value for the Mongo database environment variable would be different. To make this easy, just use the root folder name of each microservice as the value of the Mongo URI. Let's quickly create a Kubernetes manifest for post, post-up, and comments microservices. To do that, at the left side in the Explorer view, right-click Prod Manifest folder and select New File. Let's create a file for comments, comments.yaml. Right-click Prod Manifest again, select New File, and let's create manifest for post-up.yaml. And lastly, let's create a file for the post microservice. Select New File and type post.yaml. Head over to users.yaml and let's copy the contents here. So press Ctrl A, Ctrl C to copy, and then back in comments.yaml, I'll paste the copied content. Now let's update the values for comments.yaml. Wherever there is a users keyword, replace it with comment. So with Ctrl F, I'll search for users and then click the button beside the search field and replace this with comments. You can click the replace all button to replace all the content at once. Every other config would practically remain the same. Let's close this search box. Recall in our applications architecture, we have an event bus where microservices will publish events or subscribe to events from other microservices. We would eventually define a deployment and a service for the event bus, but for now, since I know the value I plan to use, we will just define the env values for our comments microservice to communicate with the event bus. In our code, there is a process.env.nats cluster ID, client ID, and URL defined for communicating with the event bus. This is necessary so we don't hard code values in the application that can possibly change in the future based on environments. So we would update the env section of our container, adding fields for the NATS cluster ID, client ID, and NATS URL. Let's scroll to the deployment section, and where we have containers just after JWT key variable, create a new line and go back 4 steps. Then type dash space name, colon, and we'll call this NATS underscore cluster underscore ID. Enter, press tab, and the value would be post hub cluster. Enter. Let's create a new environment variable, name, NATS underscore client underscore ID. And this would be taken from the container's name. So we would use value from colon, enter, press tab, field ref, colon, enter, press tab, field path, colon, a name set as metadata.name. Let's create the last variable, name, which will be nats underscore URL, and the value would be http colon /nats dash event hub dash service colon 4222. The NATS event bus requires a cluster name, which for this application is called post-up cluster. The NATS URL value is a service which would be configured for a NATS container very soon in the course. You can connect to any service in the same namespace via HTTP to the service name. Lastly, we have the client ID environment variable, and you would notice that we reference a name gotten from the deployments.metadata. This is necessary so that we have a unique name for each microservice that publishes to the event bus and would aid troubleshooting if there are errors communicating with the event bus. That's all we need to do for the comments manifest file. To replicate these and save time, I will simply highlight and copy the contents in this file using Ctrl A and Ctrl C to copy. So press Ctrl A, then Ctrl C to copy, head over to postup.yaml and paste the content. Now let's search for anything with comments and click the button beside the search field and replace it with postup. Click replace all button. Let's do the same thing for post.yaml. Go to post.yaml, paste the copied content, and then replace all comments keyword with post. Click the replace all button. And that's it. Let's close this. So this might seem like a long process, but the cool thing about this is it's a one-time activity. Once you've defined your Kubernetes manifest for each microservice, future changes are quite simple. Our application requires databases to store and retrieve information. For this course, we would use container-based Mongo database to demonstrate how different microservices connect to their own database, effectively being in charge of the original data. We will quickly define deployments and services objects for comments, post-up, post, and users Mongo databases. And lastly, we will define our event bus manifest. So let's head over to the root K8 folder and create some files. So on the left side of your IDE in the Explorer view, right-click K8 and then select New File. Let's create the Mongo file for comments. So type comments-mongo.yaml. Right-click K8 again, and let's create for post-up mongo.yaml. We'll do the same thing. Right-click K8, new file, and let's create for post-mongo.yaml. And lastly, for users, so right-click, select new file, and type users-mongo.yaml. Back in the comments Mongo file, I'll define a namespace object. Simply type namespace and select the namespace code snippet. Update the namespace value from name to ns-postup-env. Use the same value for labels.name. So create a new line, type labels, enter, tab, then name, ns-postup-env, double dash. Let's add the 3 dashes separator and define a deployment. So create 3 new lines, go back to the beginning of the line and type 3 dashes. Press enter. You can simply type deployment, select Kubernetes deployment code snippet as we've done before, and add more parameters required for our comments Mongo database. but I will simply paste my deployment manifest I created earlier. So this is a little bit different from the manifest we defined for our backend microservices. You see here that the image value is simply Mongo, and this image would be pulled from Docker public repository. But if you have a custom Mongo image in the organization, you can specify that here. As usual, we have resources request and limits so that the pods are deployed in a node that has enough resources available. The default Mongo port of 27017 is used here, but you can always use a different port for the container or in your service to max this default port. So after this, let's create the 3 dashes separator. So create new lines and go to the beginning of the line and type the 3 dashes separator, then enter. I'll simply paste my custom code snippet again for services. The name is comments Mongo service. Recall that the name is referenced in our comments manifest file as the value of the Mongo URI. Let's confirm that by heading to prod manifest, click on comments, and you can see here we have the Mongo URI set as comments-mongo-service. Back in the comments Mongo file, you'd see that the service type is cluster IP because we want the service to only be reachable inside the cluster and not out there over the internet. The port of the service is 27020, while the target port is 27017 as defined in the deployment object. That's basically all we have to do for our MongoDB manifest files. To make things a bit faster, you can copy the contents here and paste it in post.mongo, postmongo, and users mongo manifest. Afterwards, find and replace the comments with their appropriate file names, for example, with post-up, post, and users respectively. Alternatively, you can simply download the source code for this video with all the manifests defined for the course. All right, I know defining manifest in this course seems like an unending task, but I promise this is the last one. Recall earlier in our architecture discussions that we have an event bus for microservices to publish and subscribe to events. In this course, we would be using NAT Streaming Server. You can read the docs about the tool on the website to understand the concepts and features it has, like historical message replay, where new subscriptions, also known as microservices, can receive old events published while the microservice was not running. This enables data consistency across your application designed with a microservices approach. It also has a durable subscriptions feature where an active microservice receives newer messages after a restart or crash. In this course, we will create a simple setup of NAT streaming without using mounted volumes or fault tolerance setup, but the docs can guide you with that if you wish to explore further. Let's simply create a file called NAT event hub under our K8 folder. So at the left side of the screen, right-click K8, select new file, and then type nat-eventhub.yaml and enter. Simply type deployment, DEP, and select Kubernetes deployment code snippet. First of all, let's add a namespace field to our metadata so that the pod is only deployed in the same namespace as other services. So create a new line after metadata.name, and let's call it namespace colon ns-posthub -env -. Next, replace my app keyword with the file name, which is nats-event hub. Let's click on my app and then press down the Alt key and double click the rest of them. Then replace it with the value nats-event hub. To know the image tag to use, you can check out NAT streaming images on Docker repository, but I will just specify here nats-streaming :0.24.0. We need an array of arguments for this NAT streaming service. I'll simply paste the values and then we check the docs together to understand the basic parameters defined here. So just after the image field, I'll enter a new line and then type args. It's a colon, space, and then paste the values. Let's head over to the command line arguments on the NATS website. The -HBI parameter in duration is the interval at which the NAT server sends a heartbeat to a client, and -HBF, an integer, is the number of failed heartbeats before NAT streaming server closes the client connection. If you scroll down, you will find where we have -P, which represents the streaming port, and the default is 4222, while the -M parameter is the monitoring port. You see here we have -SD parameter, which is for debugging and is a boolean to enable stand debugging logs. And at the top where we have -CID, this represents the cluster ID, which in this case is post-hop cluster. Recall that we defined this value in env for the backend microservices. If you would like to add other parameters, you can simply read about the use case and modify your arguments accordingly. Back in my terminal, I will update the resources limits for memory to 2000 megabytes. So select the memory value and change this to 2000 MI, while the CPU value would be 1500 milli-CPU. Let's create a new line to add request parameters. So create a new line, press tab, and type request memory with a value of 500 MI, and then CPU with a value of 500 M. You can delete the ports config as this is already defined in the arguments section. So delete this. Now we are done with defining the deployment object. Let's define the NAT streaming service. I'll simply create new lines, go to the beginning of the line and type the 3 dashes separator, then press enter and paste the content I've defined earlier. You see here we maintain the same namespace as ns post-up --env. The service type is cluster IP, as this service should not be reachable directly over the internet or outside the Kubernetes cluster. We have 2 ports defined, one for the client and the second for monitoring. Recall we have -P and -M arguments in the deployment object. I promised that this would be our last manifest to define. So we have manifests for our backend and front-end services, as well as other infrastructure like the database for each microservice and the event bus manifest. Once you define this manifest, it's quite easier to adopt them for new applications developed with a microservice approach. You can simply have a template for different types of services and modify that when necessary for the new application. I am excited we are done defining the manifest for our microservices and related infrastructure. Let's explore the Azure Kubernetes architecture for our containers and various related resources we have to configure. There is a site you can check out to review some architectural diagrams and adapt one to the application you wish to deploy to Azure Kubernetes Service. The site address is displayed on the screen, and it has several AKS related architectures if you filter by choosing containers under categories. So just review what would work best for your use case and adapt it to your microservices design. One of the architectures, the advanced AKS architecture, has two isolated virtual networks paired in a hub-spoke network topology. In the hub virtual network, Azure Firewall and Bastion subnets are deployed, and this would act as an entry network to resources in the spoke network. For example, an administrator that wishes to connect remotely to the AKS cluster from an on-premise network, and the firewall that would inspect egress traffic from the spoke network to other resources like external databases, service bus, etc. So if you would like an advanced setup, you can review this baseline. In this course, we would not deploy hub-spoke topology with firewalls and external databases. Instead, we would adapt a basic architecture with a single virtual network for the AKS and an application gateway to route traffic based on the URI path defined in an ingress resource. We would also configure Set Manager and Let's Encrypt to automatically obtain a TLS certificate for our post-op application. If you have purchased a domain name and want to acquire certificates for your custom domain, you can integrate Azure DNS in your setup and configure Set Manager to automatically issue custom domain SSL certificates. Notice that an application gateway instead of a layer 4 load balancer is used in our setup for ingress traffic. Azure Application Gateway is a layer 7 load balancer and provides an optional web application firewall feature that, when enabled, inspects and blocks malicious traffic to your cluster. Combine these features with Application Gateway Ingress Controller, and all you have to do for new services in the cluster is define an ingress to expose and direct HTTP or HTTPS traffic to that service. There are quite a number of features in Azure Application Gateway that will be useful with your Azure Kubernetes service, so check out the docs to learn more. But some of the benefits of using an app gateway are: it eliminates the need for multiple load balancers per service that's defined as a load balancer kind. All your services can be deployed with cluster IP setup and linked to the ingress controller. You now have better control over your network design. Application Gateway has auto-scaling capabilities, allowing it to spin up more instances depending on the traffic requirements, and this happens outside of the cluster, effectively allowing better performance of your cluster without tying down cluster resources. And lastly, the Application Gateway is a layer 7 load balancer that can route traffic based on the URI path for multiple microservices hosted in the cluster. And the best of it, it implements TLS termination for your microservices. One thing to note when planning to use Application Gateway is that you have to deploy your Kubernetes cluster with advanced networking configured, because the Application Gateway would be deployed in a separate subnet of this virtual network, and basic Kubernetes networking does not support Application Gateway integration. There are a couple of ways to deploy AKS, for example, through the Azure portal, Azure CLI, using ARM template or Terraform. In this video and throughout the course, we would use a mix of Azure CLI and Azure portal to set up the AKS as well as the container registry and application gateway. First, open your Azure portal by browsing to portal.azure.com and sign in with your credentials. If you do not have a profile on Azure, you can sign up with your Outlook account and you get some free credit to spend on Azure resources. To access Azure CLI, just after the search bar at the top of the portal, click the Cloud Shell icon. I'll need to maximize this, so click the Maximize button. And if this is your first time to use Cloud Shell in your Azure subscription, select Bash instead of PowerShell and click the Create Storage button. If you have multiple subscriptions on Azure, make sure you choose the right subscription you have access to for these deployments. To begin our AKS deployment, there are some parameters we will need to define across commands. So we will be using variables in Bash to pass values for these parameters. I've already uploaded my script for this video to the cloud drive in Azure Storage, so let me quickly open that. So I'll select the Open Editor, expand Cloud Drive, Exercise Files, Chapter 3, and for this video, I'll open the AKS deploy commands. Let me resize the window. We need a resource group, location, virtual network name, addresses, subnet names, and other parameters defined in the commands. So rather than define those things individually in each command, you can assign the values to a variable and reference that in your command. Let's quickly execute the first set of commands. So I'll copy this with Ctrl+C. Right-click in the Azure CLI window and paste the command, then enter. For our virtual network, let's also copy the sets of commands we have here. Highlight, copy, and paste, then enter. For our AKS resources, we have to define the following parameters. So highlight, copy, right-click in Azure CLI window, paste and enter. Before creating the AKS cluster, we need a resource group as well as a virtual network. So let's copy the create resource group command. Copy this and execute. A resource group with name AKS-RG is created. The next command is to create the virtual network. So I'll grab the command, paste here, and execute. Now that the virtual network is created, let's create the AKS resource. We need to retrieve and store AKS version and subnet ID to a variable so that we can use them in the AKS create command. To do that, I would copy this command to retrieve the subnet ID, paste here, and execute. I'd also do the same thing to retrieve the AKS version, which would likely be the current version. Paste and execute. To improve security of our cluster and enable access between the cluster and external resources like Azure DNS, etc., we have to create a managed identity in Azure Active Directory. This will help with assigning role-based access control, giving an administrator better control over resources that the cluster can access. You should note that you can also use a service principal, but to eliminate the need for manual password management for a service principal, I'll be using a user managed identity. Let's copy this command to create a user managed identity. Control+C, paste that in the CLI window and enter. Awesome. Let's retrieve the service principal ID of this user managed identity and assign it to a variable. So we'll copy this command to retrieve and assign to sp_id. Enter. Let's also retrieve the unique ID of the user identity. and assign it to a resource ID variable. Control C, paste, enter. Now we need to create a role assignment with the retrieved IDs. So I'll scroll down and copy this command. Control C, paste. This will create a role assignment for the service principal ID, and the role will be a managed identity operator, and the scope would be just the resource ID, and the assignee principal type is service principal. So press enter to run this command. Finally, it's time to deploy our AKS cluster. So I'll copy the AZ AKS create command, highlight this, copy and paste in the CLI. This will create an AKS cluster in the resource group which we specified. The AKS cluster name would be from the variable we defined earlier. The VM set type would be virtual machine scale set. The number of nodes would be 3, and location would be East US. The Kubernetes version would be from the retrieved parameter we ran earlier. The network plugin would be Azure, which is an advanced networking option. The VNet subnet ID would be assigned to the variable we defined. And the Kubernetes service subnet, that is the service-CIDR parameter, is a range of IP addresses that is only ever used inside the cluster and assigned to services created in the cluster. The DNS service IP is a single IP for DNS within Kubernetes service subnet range, but this can't be the first IP in that range. A kubelet identity enables scenarios such as connection to the ACR with a pre-created managed identity. I'm using the same identity here, but you can decide to create a different kubelet identity and reference that in your AKS create command. So let's press enter to run this. This might take a while, so we'll come back to this once it's completed. Awesome. Our cluster has been deployed successfully, and we can confirm by checking, for example, how many nodes are available. To do that, we first need to authenticate to the AKS cluster by running the AKS get credentials command. So I'll copy this, paste in the CLI window. I'll overwrite this because I have some config already for a previous cluster. And then let's run the kubectl get nodes. And we should get 3 nodes present in the cluster. Awesome. You can see the age, meaning this was just deployed recently, less than 2 minutes ago. So that's basically how to deploy your AKS using Azure CLI. Ensure to follow through with the next couple of videos to use the same Azure CLI session, otherwise the parameters we defined earlier would be lost. If that happens to you, you can simply redefine the variables as we did earlier in the video. There are several registries to store container images. We have the Docker Hub, and in Azure, there is Azure Container Registry, ACR. This is a private registry and allows you to build and securely store your container images. You can also enable role-based access control to restrict access to the container registry, giving an administrator better oversight. In this video, we would create an Azure Container Registry and link it to the Azure Kubernetes service we created earlier so that AKS can pull container images from the ACR. We will continue using Azure CLI as we have defined some variables. The ACR would have to be deployed in the same resource group, so variables defined in the previous video are still useful here. If your session has expired, you can redefine the variables. Let me first open the file where we have the commands for this video. I would like to create a random name variable just to create a unique value for my ACR instance. To do that, I'll copy this command and paste that in the CLI. Then enter. To create the Azure Container Registry, we use the AZACR create command and reference the name variable created just now. So I'll copy these commands, copy, right click in the CLI window and paste, then enter. To confirm that the ACR is created, you can check the resource group via the portal or run AZACR list. For our AKS cluster to authenticate to the Azure Container Registry, we have to update our AKS cluster using AZAKS update command. So let's copy this command, Ctrl C, right click and paste, then run. If you've got an error while trying to run the AZAKS update command, make sure you run the AZAKS get credentials to authenticate to the cluster in the appropriate resource group, and then run the AKS update command again. That's how to deploy and attach an Azure Container Registry to an Azure Kubernetes Service cluster so it can pull container images from the linked private registry into the cluster. One major benefit of using an application gateway with an ingress controller is that there is no need to have multiple load balancers and public IP resources for each service you wish to expose from your AKS cluster. You save cloud costs and improve performance of your overall Kubernetes setup. The Application Gateway Ingress Controller monitors your AKS cluster and updates the integrated application gateway of new changes so that linked services are automatically exposed to the internet. With its Layer 7 load balancing feature, requests to your services can be routed based on the URL path. For example, HTTP requests to API/users would route to the user's microservice, while HTTP requests to API/comments are routed to the comments microservice. Let's quickly deploy an application gateway and enable the application gateway ingress controller as an add-on in the AKS cluster. For simplicity, the app gateway would be deployed on the same network. First, let me clear my CLI and then navigate to the commands for this video. We'll need to define some variables as we did in an earlier video. Note that if your previous session expired and you still want to reference the variables defined earlier, you have to define such variables again, like the resource group, location, VNet name, etc. So I'll copy the parameters for this, copy and paste in the CLI, then enter. Let's create a standard public IP resource for our application gateway. So I'll copy the commands to create a public IP and paste that in the CLI, then enter. For application gateways, you have to deploy a standard public IP resource instead of a basic SKU. Now let's create a subnet in our existing virtual network for the application gateway. To do that, I'll copy this command, paste this, and enter. After creating the subnet, we can now deploy an application gateway in that subnet and link the public IP address. So to do that, we have a command here for AZ network application gateway create. So copy that and paste it in your CLI. It will create the application gateway in the same location and resource group. The application gateway SKU is standard underscore v2, and it will be linked to the public IP address variable we defined earlier with the VNet name as well. Press enter to run. This might take some time to deploy, so we'll come back to this once it's completed. Now that the deployment is completed, we need to retrieve the app gateway ID into a variable so that we can reference that when enabling the ingress controller add-on in the AKS cluster. So let's copy the commands to retrieve the ID and enter. And finally, we need to enable the application gateway ingress controller add-on in the cluster to use the application gateway we've just created. To do that, let's scroll down and copy the AKS enable command. Then enter. This might take some time, just as we experienced in the previous video, but if your AKS enable add-on command fails due to authentication issues, simply run the AKS get credentials command for your cluster. And that's it for creating an application gateway linked to the Azure Kubernetes cluster. You can read the docs to understand how Web Application Firewall works and use it in your future project to protect your Kubernetes cluster from malicious traffic. Security is one of the pillars of a well-architected cloud platform. Therefore, it's important to encrypt communication between your web application and users using a TLS certificate. We will install a Kubernetes add-on called Set Manager to automate the creation and management of TLS certificates in the cluster. The Set Manager will be configured to use Let's Encrypt, a non-profit certificate authority, as the issuer to obtain a certificate for a microservices domain. The obtained certificate will be installed on the application gateway to perform TLS termination for the cluster. Apart from the automation with obtaining certificates, Set Manager ensures that certificates are renewed before expiry. Our initial configuration of Set Manager will be with Let's Encrypt Staging API instead of the production API. The production API has rate limits enabled, and it's possible you can exhaust the limit while troubleshooting your Set Manager verification process. You can check out Set Manager documentation via the link displayed on the screen to learn more about this. Before we start, let's navigate to the commands for this video. So expand 305 and open Set Manager deploy. Let me close this. We need to first add jetstack helm repository. So to do that, let's run this command. So I'll copy this and paste it in my CLI and enter. You should get an output like this that says jetstack has been added, or if it already exists, it will show that. Let's run this next command to update the cluster's helm repository cache. So I'll copy helm repo update and paste that just in case. Awesome. The next command will create a namespace called Set Manager in the cluster and install the Set Manager add-on with the necessary custom resources. So let's copy these commands, Ctrl C, and paste that. Awesome. That's all the steps involved in installing a Set Manager. Make sure you find in the log that Set Manager was deployed successfully. If you scroll up, you can see that here. The next step would be to create an issuer resource. There are two kinds of issuers, the namespace issuer and a cluster issuer. As the name implies, issuers are restricted to the namespace they are deployed in and can't issue certificates across namespaces. A cluster issuer, on the other hand, can issue certificates across all namespaces in the cluster. And that's what we will deploy now, such that the cluster issuer will instruct Set Manager to issue certificates using the Let's Encrypt staging environment. We will create the cluster issuer by running an inline script or manifest. This is usually a 1 or 2 time action, and ensure to modify the email address in the script. So back in my Docker file, modify the email field to reflect your email address. This would be used to validate that you own the cluster where you're trying to issue certificates from. So let's copy this command from kubectl apply all the way to EOF. Copy, and in the CLI, paste the copied commands and enter. A cluster issuer resource is deployed into the set manager namespace. Notice the server API has staging in it. This is to ensure that verification works properly. To change this to production, you will simply remove the staging keyword, or you can check the docs to confirm the current API use. Private key reference is the name of the secret used to store our certificate account's private key. You can run kubectl get secret-n set manager, and you should see let's encrypt staging secret active for a few minutes now. Let's do that. Kubectl get secret -n means the namespace and set manager. Awesome. You have the let's encrypt staging, which was installed about 66 seconds ago. The spec.acme.solvers section is where you define the challenge method to verify ownership of the domain. There is HTTP 01, which requires a particular file is available at the domain to prove that you have access. And there is DNS 01, which automatically creates a TXT record in your DNS to verify ownership. We won't go much further into this, but with this setup, you can easily integrate Azure DNS, get a custom domain, and issue custom domain certificates for your cluster. Now that we have our AKS cluster and Azure Container Registry, let's try to manually deploy one of our microservices. We will run the UI microservice since it does not require some environment variables defined in the cluster before the container can run. Later in this course, we would use CI/CD pipelines to automatically create an image, push to the Azure Container Registry, and apply the manifest to the Kubernetes cluster without human intervention. This will enable a consistent workflow for our software delivery. Recall that in one of the earlier videos, we built an image for our UI microservice. To confirm that you still have that image, you need to run the Docker images command in your terminal. So to open the terminal, at the top menu, click the View menu and select Terminal. Once the terminal is loaded, let's run Docker images, and I'll be filtering for image with UI keyword. Great, I still have my image. If you're not sure of your image or you don't find any image in your Docker images result, you can right-click the UI folder, select the Open in Integrated Terminal, and run the Docker build command to build a new UI image. To upload our image to the Azure Container Registry, which is a private registry, we need to log in first to Azure and then log into the ACR. So let's run AZ login. This will prompt for your credentials. You'd select the credentials. And just before we head back to the terminal, I need to find out the name of my Azure Container Registry. So I'll open my Azure portal, and then I'll check the AKS resource group, and I can see here I have ACR 12242. Yours might be a different number since we used the random parameter to deploy the ACR. Let's head back to our terminal. The login was successful, and you can see a list of subscriptions that are registered to your profile. Now let's log into ACR by running AZ ACR login. So AZ ACR login --name ACR 12242. Press enter. You should see login was successful. We will now tag our UI image with the server address of our Azure Container Registry so that we can seamlessly push the image to ACR. To get the server address, you can check the ACR overview page on Azure portal or run this command in your terminal. So I'll copy the get ACR address command, paste it in my terminal, and then enter. Awesome. With this information, we can tag our UI image with the login server address of the private Azure Container Registry so that we can push the image not to Docker Hub, but to Azure Container Registry. Let's run the docker tag command to tag our UI image. Before I do that, I'll need to change the value here to reflect the name of my registry. Then copy and paste here, then enter. Let's verify the image by running the docker images command again. Docker images grep UI. We now have an image with the ACR tag in the list of images. Let's push this to the private registry. But first, just to verify the image name is the same as what's defined in the exercise file, let's open the demo UI file and then check where we have containers.image and modify the value here. This should reflect the same name you gave to your image for the ACR. Ensure to save the file and let's go back to our app deployment file. Scroll down and then let's push the image to the ACR. To do that, we'll run in the terminal docker push. Let's copy the ACR name /UI version 1.0. Then enter. This will take some time to push the image to the Azure Container Registry, so let's wait a bit and then come back to verify that the image was pushed. Awesome. Now that the push is completed, let's verify the image is in the Azure Container Registry by running the AZ ACR repository list. So you can copy this command or simply type AZ ACR repository list -- name ACR 12242 output table and enter. The result shows that a UI image exists in the Azure Container Registry. Alternatively, you can check the ACR repository through Azure portal to confirm that the image exists. Now that we have an image for our UI in Azure Container Registry, let's test a deployment to our Azure Kubernetes service. Note that these steps are not really necessary, especially if you plan to automate your deployment using CI/CD pipelines or GitHub Actions. We are only exploring manual deployment of container images to the AKS cluster as a test. Let's quickly switch folders to the directory of the demo UI manifest so that I can easily reference the manifest. On the left side in the Explorer view, I'll right-click 03_06 and select Open in Integrated Terminal. Before you can deploy to AKS, we have to connect to the Kubernetes cluster. So let's run the AZ AKS get credentials to connect. AZ AKS get credentials, resource group. Recall that the resource group is AKS-RG and the name of the cluster is AKS-cluster-01. Enter. Because I already have a config, it wants to override, so I'll select yes and yes. Awesome. Let's confirm that we are in the cluster. So I'll just run kubectl get nodes. Awesome. If you have an error while running the AKS get credentials command, simply run AKS install CLI in your IDE to install kubectl locally. To deploy the UI of our application to the AKS cluster, let's run the kubectl apply command. So kubectl apply with -f parameter demo-ui.yaml, then enter. That's simple, right? The namespace we defined in the manifest file is created. Same with the deployment and service objects. To verify that the deployment was successful, let's run kubectl get ports command. So kubectl get ports, and we have to specify the namespace. So ns-posthub-env. Enter. Great. We see a port for the UI, which is in the running state. And if you want to see other related ports, services, deployments, etc. in this namespace, you can simply replace port with all and run kubectl get all command. So let's try that. I'll simply delete ports. Let me expand this. You now have more objects listed, like the pod, which has only one instance running, the service that exposes the UI port to HTTP requests. Recall that we defined the type as cluster IP instead of load balancer or node port. So this would only be reachable within the cluster. Later in the course, we will define an ingress link to the application gateway to expose our service to the internet. We also have a deployment which we defined in the manifest. It shows a single replica of our UI microservice is available. The first number represents the ready state, while the second number represents the desired state of the deployment. Up-to-date displays the total number of replicas updated to achieve the desired state, and age represents the total time the application has been running. And lastly, we have the replica sets, which shows the desired number of replicas for the UI application, the current number of replicas in the running state, and how many replicas of the application are available to receive traffic. There are a number of other commands you can run, like kubectl describe deployments or pod. Let's run the kubectl describe pod command. You can see the command in the README file for this video. I'll simply type in the terminal kubectl describe pod, and let's check for the pod name. Paste and specify the namespace. Then enter. Here you will see details about the object you run the describe command. For example, for this UI pod, we can see, if you scroll up, we have the namespace, the start time, the labels as described in the deployment object, and we have the IP address for this container or pod. We have the container ID, the port, which is used to access this container, and the state. You can scroll down, you'd see events such as pulling image from the container registry, and it successfully pulled the image and then created and started the container. The manual process for just one microservice seemed daunting, right? Imagine doing this for 10 microservices a day if you have a large development team. It starts becoming mundane, taking up time for any productive activity. So we will see how to use CI/CD pipelines in Azure DevOps to automate this process so that developers can easily push to the repo and the pipeline is triggered to create, push an image, and deploy the application to the AKS cluster. Manually deploying microservices to a Kubernetes cluster is really time-consuming and prone to errors. We witnessed that while deploying our front-end microservice to the AKS cluster in the previous video. Think about doing that for a new or modified application 10 or more times in a day, and you would be exhausted even thinking about it. Azure DevOps has tools such as the CI/CD pipelines to help teams automate the build and deployment of microservices to the AKS cluster. Using a monorepo approach or similar setup, a developer can commit code to a feature or development branch in Azure repo, set up a build pipeline to monitor the microservices folders for changes, and trigger a new build. The build pipeline would include tags that build the application as a container image and pushes it to the Azure Container Registry. A release pipeline is configured such that a successful build would trigger the release pipeline, and based on the branch being monitored, the appropriate reference container image is deployed to the AKS cluster using kubectl apply command. And then your users can access your application over the internet, or if it's meant to be an internal microservice accessible only within the cluster, then other services can reach your deployed container in the cluster. To improve security, you can integrate code or container analysis tools in your CI/CD pipeline setup, or enable it in your private registry to scan your source code or containers for vulnerabilities. Setup is usually done once, but you can continuously optimize the Azure pipelines to meet the demands of the team. This way, you are able to deliver code faster and safely to your users without errors. You also improve feedback as pull requests are discussed right there on the Azure DevOps platform, and rollback is absolutely seamless if a new change in a critical environment like the production needs to be rolled back. For simplicity in this course, we will use only a single AKS cluster with 3 nodes and deploy our microservices with suffixes like -dev, -test, and -main as part of the namespace value. We will also explore branch policies for pull requests into the main branch to simulate collaboration or feedback loop and an ability to compare changes before merging into a critical or production branch. And since we have multiple microservices, we would make use of task group, which is a feature in Azure DevOps to design a pipeline template and plug it into different pipelines you'll build in the future. Let's quickly set up our Azure DevOps project and commit our source code to Azure repos. If you're not registered on Azure DevOps, you can quickly head over to your browser and type dev.azure.com, then click the Start Free button. In the next page, provide your personal Outlook account or create one if you do not have an Outlook profile, then follow the steps to create a DevOps organization. If you have an account, simply click the Sign In to Azure DevOps option, then provide your credentials to proceed. Once you're logged in, at the top right corner of the portal, click the New Project button. Let's name this project Post Hub with a small letter. You can provide a simple description if you want and select the public or private visibility option. I'll leave mine at private. Expand the advanced option, and you'd see here we have Git version control enabled, and the work item would be basic. Click the Create button. Once the project is created, on the left side of the screen, let's navigate to Repos. And since I have an existing source code for my project, I would choose the Push an existing repository from the command line. So let's highlight this command and copy. Back in my IDE, I'll make sure I'm in the root directory of my project, and then let's change the branch to main. So click on the branch menu on the lower left corner of the screen, and then I'll select origin main. Let's paste the command we copied and rename the remote from origin to AZDevOps. So right click to paste and replace origin with AZDevOps. That will be the name of the remote. Then enter. Awesome. To push to the repository, let's run the git push command. So git push -u AZDevOps, which is the name of the remote, and then main. This might take some time, but once it's completed, you should find your code in Azure repos. Awesome. Let's head back to Azure repos on the browser and refresh the page. Here you go. Our code is now in Azure repos, and we can configure CI/CD pipelines to monitor the repo for changes and trigger a build and release to the AKS cluster. Before we configure a CI pipeline, let's quickly define the K8 manifest for our ingress resource. In the Explorer view of the VS Code, expand the K8 folder, right-click prod manifest and select new file. The name of the file will be ingress-service.yaml. Enter. So that we don't spend much time, I'll simply paste my code snippet for an ingress resource, and we will review together the various sections. If you'd like to define yours using the code snippet suggestion, type ingress keyword and select the sample listed, then modify the fields to suit your application design. Let's go through the manifest and understand the various fields. As usual, we have the API version indicating the object we wish to define, in this case, a networking object of an ingress kind. In the metadata section, the name value is defined, and the namespace field has the same value as defined in other manifests. Recall that the env keyword represents the environment, like dev, QA, etc., and would be substituted in the pipeline we will define later. Annotations are arbitrary key value pairs used to represent a Kubernetes ingress resource. In this case, we define some metadata that the Azure Application Gateway Ingress Controller can use to modify the application gateway features. Without these, your ingress will not deploy the desired state of ingress in the cluster as defined in the manifest. This is why we have this key kubernetes.io/ingress class with a value of Azure/application gateway. There is a different annotation if you are using Nginx or any other ingress resource. We have other annotation keys such as the TLS redirect, which is set to true, and the cluster issuer, which is set as let's encrypt staging. To learn more about annotation keys you can use in your ingress for Application Gateway Ingress Controller, you can check out the site displayed on the screen. In the spec field, we have the TLS section with a host defined and a secret name, which is a reference to a secret that will be created in the AKS cluster for a certificate bearing this domain name. We also have a set of rules. First, the host is defined for this rules section, and then we have the http.path where you define the URL path of your microservices and reference the appropriate service to map request. For example, we have a defined route in our application for API/postup. So anytime a request is made to the AKS cluster and the request has a path matching /API/postup, such requests would be routed to postup microservice on port 3000. For API/post, traffic is routed to post service on port 3000. Recall that in each microservice manifest, for example, comments manifest file, we define the service object and a port of 3000. That is why you have port 3000 set here for each service in the ingress resource rules section. The last rule is for traffic to the root URL, which would be routed to our UI microservice, acting as the front-end application. Notice how the rules were defined from a more granular path at the top down to a less granular path. If you reverse this arrangement and define the root path first, then requests that match another path after the root path will not reach the appropriate microservice and end up being routed to the root. So path processing starts from the top or first rule to the bottom, and it is therefore important that you define granular paths first and your root path as the last or catch-all. You can check out the link displayed on the screen to learn more about path-based routing rule. Before we commit our ingress file, let's check the application gateway resource in Azure to retrieve the public IP and modify the domain in the ingress file. Open your Azure portal and in the search box at the top of the portal, type Application Gateway. Click the Application Gateway result and I'll filter my subscription to pay as you go. Then open my Application Gateway. Once the overview page of my Application Gateway opens, there I'll find my IP address for my Application Gateway. Simply copy that, and then let's head back to our manifest file. And where you have the IP in your host name, let's replace it with the IP of our Application Gateway. So paste this here, and also paste this here. We also need to modify the IP in the environment variable for the UI application. In the Explorer view, expand your UI folder, and then look for .env file. Open that, and in it, let's replace the IP address we have here. Now that we are done with these changes, make sure to save your files. And it's time to quickly commit and push the change to our repo. To do that, I would open my terminal, and then I'll type git add dot to stage the files. I'll type git commit to commit the changes to the repo, -m, then the comment, which will be added an ingress manifest. And then to push to our Azure DevOps repo, I'll run git push -u az DevOps, then main. Enter. Great, that was successful. Let's check our repo in the browser to be sure this was pushed. So I'll head over to my browser, open my post-up project, and refresh the page. I can see here that new changes was pushed, and it shows just now as the last change date. There are two ways to configure a pipeline in Azure DevOps. One is the classic, and the other is by defining a YAML file. For this course, I will use the classic method. Since we have multiple microservices and each of them would require their pipelines, I will try to simplify the configuration for future pipelines by creating a task group. With a task group, I can create, build, or release pipeline template with variables that can be defined depending on the pipeline to be configured. Before configuring the build pipeline, let's assume that our Git branching workflow would have dev, test, and main branches. Git workflow decisions are quite flexible and depend on your team size, project size, or software development style. And since we have only a single cluster deployed in this course, to simulate deployment to a dev, test, and production namespace, we would need to substitute the env keyword in our manifest files. If you have a separate cluster for development and production workloads, which is ideal, then the setup would likely be different. Let's quickly create 2 more branches in our repo, dev and test. Make sure you are in the repos page, and at the top, select the branch menu, click new branch, and type dev. Then click the create button. Let's repeat the same process. Select the branch menu, click new branch, and type test as the name of the branch. Then click create. To prevent direct pushes to these branches and require a pull request, let's quickly set branch policies. On the left pane, under repos, click on branches. We will define basic policies. So for the main branch towards the right side of the list, click the ellipsis and select branch policies. Toggle the require a minimum number of reviewers and change the value to 1. Also check allow requesters to approve their own changes, since it's only you working on this project. Typically, you would leave this unchecked if working with a team of developers. Let's repeat the same process for dev and test branch. Click the dev branch, toggle require a minimum number of reviewers, change the value to 1, and check the allow requesters to approve their changes. Let's do the same thing for test. Toggle, change the value to 1, and allow requesters to approve changes. Next, let's start with configuring a pipeline for our UI microservice. Navigate to the pipelines page on the left pane and click pipelines. Select create a new pipeline. Choose the use the classic editor option. Confirm that the right repository and default branch is selected, and then let's click the continue button. Let's choose a Docker container template and then click the apply button. Make sure you're in the pipeline page and select Ubuntu as the agent specification. Click the drop down, search for Ubuntu letters. Click on the build an image task. Then let's select the Azure subscription. Click the drop down. Select your Azure subscription. For me, it's pay as you go. Then click the authorize button. Once authentication is successful and you have a service connection created to your Azure portal, you should find the ACR we deployed earlier in this course. Click the drop-down menu under Azure Container Registry and select your ACR name. You can confirm the ACR name in the overview page of your ACR in Azure portal. Let's scroll down, and in the Docker file field, replace the double asterisk with a parameter, which will be named microservice. Recall I said earlier that we need to create a task group so that we can easily use the same pipeline definition across multiple microservices. So this variable $sign microservice in brackets represents the root folder of each microservice and also represents the microservice name. So in the image name field, I need to modify the values we have here. I would simply delete this and then type build.repository.name $$ in bracket build.source branch name close bracket $$ bracket microservice close, then colon dollar bracket build.build ID, close bracket. This will reflect the repository name, the specific branch name, and the microservice name with the build ID as the image tag. You can leave other settings as it is and then click on the push an image task. Select your Azure subscription, click the drop down and select pay as you go. And then click the drop down for Azure Container Registry and select your ACR name. I need to replace the values for the image name, so I'll go back to build an image, copy the image name here, go back to push an image, and replace the values in the image name field. It's important to save your pipeline often so you don't lose your configurations. So let's rename the pipeline to AKS CI UI. Click the Save and Queue button, select Save, and then click Save button to save the pipeline. We need to define a replace token task to substitute variables in the manifest of our microservice. So let's click the Add button beside the agent job and search for replace tokens. If you do not have the extension installed already on your organization, you can click the Get It Free button and follow the prompt to install it in your organization. So click the Add button, and for this task, we want to replace all env parameters in our manifest file to reflect the name of the branch that triggers the pipeline to run. So select the task and let's parameterize the target files. I'll replace the content in target files with my copied content. These would replace env token in the microservice manifest file, the ingress resource file, the NAT manifest, and Mongo deployment for the particular microservice, as well as the env file in UI microservice. Scroll down and let's click the token pattern dropdown and select custom option. Then under the token prefix, let's replace this with double dashes. Repeat the same for the token suffix. Scroll down and expand the validation section. Then select the fill option under actions on missing variable. Let's do the same for actions on no process file. This will cause the pipeline run to fail so that you can fix the problem immediately. Expand the advanced option and let's set the default value as $, with bracket build.source branch name. This means that every env parameter in all the manifests will be replaced with either -dev, -test, or -main value, depending on the updated branch that triggered the pipeline. Since the env file would have to be updated before its use in the build image task, let's move this replace token task to the top. Simply click, drag to the top, and then drop. We're almost there. Let's add a new task to replace our image tag token in the manifest file. So click the Add button, search for replace, click Add Replace Tokens, and let's take this to the end of the task group. For this task, we want to replace the _image tag parameter in our manifest to reflect the custom image name we defined in our build and push an image tags. So make sure you've selected the tags and let's parameterize the target file. I'll highlight the target file, delete this. I'll paste my parameterized content. Change the token pattern to _ and expand the validation section Make sure to select Fail on Action for missing variables and Fail for Action on no process file. Expand the Advanced section and let's set the default value. So recall my ACR name is 12242.azurecr.io. And I'll need to copy the image tag name. So I'll go to either push or build an image, copy the image name, head back to replace token, and go to the advanced section and paste the copied content. This means that in our manifest file, wherever we have underscore image tag, the values would be replaced with ACR12242 azurecr.io, the name of the repository, the source branch name, the microservice name, and then the build ID. This value is needed for applying the manifest to the cluster in order to deploy your container. After all these changes, we need to copy the modified files from a source folder to a target folder and publish the copied files for use in a release pipeline. So let's click the Add button, search for Copy Files task, click Add. Let's also search for Publish Build Artifacts. Search for Publish Build Artifacts and click the Add button. Select the Copied Files task, and where we have the contents, we need to replace the values with the files we need to copy. So let's head over to our Replace token, copy the target files we have here, which is likely the same as what we want to copy. Then back in our Copy Files task, let's replace the value in contents with the copied values. The good thing about using an orchestrator is if there is no difference between the current state of a pod and the desired state, then the manifest will not be applied. So in this case, most times Ingress, NATS, and Mongo manifests will not deploy often. There can be some improvements to how you design your pipeline. Moving on, our target folder would be the build artifact staging directory. So I'll type this, build the artifact staging directory. Expand the advanced section and select the overwrite option and flatten folders option. Finally, select the publish artifact task and confirm that the path to publish is build.artifact staging directory. Now it's time to create a task group with all these tasks and define some default variables. To do that, simply select all the tasks by holding down the Control key and selecting each task. Right-click any of the tasks and select Create a Task Group. Let's provide a name for this task group, AKS CI task template. Let's provide default values for the Ingress, K8 folder, and NATS token folder. So for the Ingress, we'll have ingress-service.yaml. This remains the same across microservices. The K8 folder is K8s, and the NATS file is nats-eventhub.yaml. Click the Create button. You see that the pipeline automatically updates the task section with the task group we just created. The microservice parameter is required, so let's type UI since this pipeline is for a UI microservice. Let's save and run the pipeline by clicking the Save and Queue button, and then click the Save and Queue option. Select Save and Run. It will take a few minutes to run the pipeline, but you can click the Agent job to review the task. pipeline runs successfully for the UI microservice. Let's see the task. It replaced the env token. Click the replace token task to see the logs. Here we see that the env token was replaced in 4 files. The Mongo is not needed in UI microservice. That's why you don't find that here. The container image was successfully built and pushed to the Azure Container Registry. The image tag token was replaced in the manifest file, and you can click here to see the content. The 4 modified files were copied to the staging directory and published as an artifact. Let's check out one of the artifacts to be sure of the desired changes. You can click on the agent job, then click on the artifact link, expand the drop folder, and you can see here we have the .env files, the ingress service file, the NAT event file, and the UI YAML file. Let's check out our UI YAML file to make sure that the metadata.name as well as spec container image was replaced. So click the UI.yaml to download. And once it's downloaded, let's open this. And you can see here the metadata.name for the UI file is now -main. And let's also check the image name. You can see it's been replaced with the image of this microservice. This was a long one, but necessary to show you how to build a templated pipeline that can be used across microservices developed in the same programming language. Remember that the code of any of these microservices could be updated at any time, so it's important that each microservice has its own CI/CD pipeline. As a challenge, attempt to configure pipelines for the rest of our microservices in this course. Now that we have a task group template, I assure you it will be much faster to define pipelines for our backend microservices. Before we proceed to create pipelines for backend microservices, let's set up automatic build for the UI microservice, specify branches and the path to monitor for changes in our code in order to trigger a CI run. Navigate to pipelines on the left menu. Click on the ellipses towards the right of the CI for UI microservice, and then let's click the Edit Pipeline option. Click on Triggers tab, and on the right, check the Enable Continuous Integration. Since we want this pipeline to monitor the dev, test, and main branch, let's click the Add button and select Test branch. Click the Add button again and select Dev branch. Under Path Filters, click the Add button and let's provide the name of the folder to track for commits. In this case, it's UI. Let's click the Save and Queue option, select Save, and click Save. Going forward, if there is a commit to any of the branches for the UI folder, this pipeline will automatically run, build, and push the image to the Azure Container Registry. Let's start with configuring a pipeline for our users microservice. Navigate to Pipeline, and on the top right of the screen, I'll click New Pipeline. Select the Use the Classic Editor option. Confirm that the right repository and default branch is selected, then click Continue. I'll choose Empty Job. And under Pipeline, make sure that your agent specification is Ubuntu latest. Click the Add button beside the agent job, and let's search for our task group, which is AKS-CI. Click the Add button. The only thing we need to define here is the name of the microservice for this pipeline. So select the task, and where you have the microservice field, let's type users. Name the pipeline just as we did for the UI microservice. So I'll select this and type AKS-CI-users. Let's set up an automatic build for users microservice. Click the Triggers tab, and on the right, enable continuous integration. Click the Add Branch filter and select the test branch. Click the Add Branch filter again and select the Dev branch. For the path filter, you add users. Click the Save and Queue drop-down at the top. Select Save and Queue, and then click the Save and Run button. If you click on Agent Job to review the Replace Values token, you would see that the values were replaced in files related to the user's microservice. So let's click that. And you can see here we have the users.yaml file token was replaced, same as ingress, nats event of, and users Mongo, which are the two important files we're interested in for users pipeline. Now let's repeat the process for the post microservice. You can wait to check that this built successfully, but we'll just proceed. Click on Pipelines, and then select New Pipeline. Choose the Use the Classic Editor option, and make sure that the right repository and branch is selected. Click Continue. Select an empty job, and make sure that the agent specification is Ubuntu latest. So select Ubuntu latest here. Click the Add Job button, and we have a AKS CI template. So I'll click Add. And we are defining a pipeline for post microservice. So the name in the microservice field would be post with S. And let's name the CI pipeline. Replace this with AKS CI-posts. Let's set up an automatic build. Click on the Triggers tab, enable continuous integration. Click the Add button and select Test branch. Click the Add button again and select Dev branch. For the path filter, we are defining this for posts. And once that's completed, let's save and queue. Click the Save option, Save and Queue, then click the Save and Run button. You can click the agent job to review the replace token logs, but we'll just proceed to do this again for the comments pipeline. So on the left, navigate to Pipelines. Let's create a new pipeline by clicking the New Pipeline button on the right. Select Use the Classic Editor option. Make sure that the right repository and branch is selected. Then click Continue button. Select the empty job and ensure that the agent specification is Ubuntu latest. Click the Add button beside agent job and select your template. For this pipeline, we only need to define the microservice, and in this case, this will be comments. Let's rename the pipeline AKS-CI-comments. To set up an automatic build, click on the Triggers tab, enable continuous integration on the right, and let's add branch filters. Click the Add button, select the name of the branch, click the Add button again, and let's do this for the Dev branch. For the path filter, we'll type the name of the folder, which will be comments. Click the Save and Queue drop-down, select Save and Queue, and click the Save and Run button. Again, you can click the agent job to review the replace token log and confirm that the tokens are now replaced in the files for comments Mongo YAML. Finally, for the last microservice pipeline, let's repeat the process for post up. So on the left side of the menu, click the Pipelines and select New Pipeline. Select the Use Classic Editor option. Make sure that the repository and branch name are accurate, and then click the Continue button. click the empty job option and make sure the agent specification is Ubuntu latest. Click the add job button and we have a AKS CI template. I'll click the add option. Select the task and we are defining this for post-up microservice. So the name of the folder would be post-up. Let's rename the pipeline. So at the top, I'll select the name and type AKS CI post-up. Let's quickly set up an automatic build. So click on the Triggers tab and select the Enable Continuous Integration. Add branch filters for test branch and another for dev branch. Click the path filter and here the name of the folder is post-hub. Click the Save and Queue drop-down, select Save and Queue and select Save and Run button. As usual, you can click the agent job to review the steps and confirm that the tokens are replaced in the files for post-up Mongo. Notice how this was faster and easier to configure. 4 CI pipelines configured in record time. So once you have a template, it gets much faster to configure a CI/CD pipeline for your microservices. And with this template having parameters that can be defined when configuring a pipeline, all you have to do is provide the values for the parameters based on the microservice, save and run your CI pipeline to test for successful execution. We have configured continuous integration pipelines for all our microservices. This will build and push the container images to the Azure Container Registry, as well as publish some artifacts that we need in our release pipeline for continuous delivery or deployment. The release pipeline goal for each microservice is that a successful build on any branch should automatically trigger a release pipeline to deploy to the appropriate stage, such as the dev, test, or prod environment. Let's get started by navigating to Pipelines, then click Releases. Click New Pipeline, and in the template list, search for Kubernetes and click the Apply button for the Deploy to a Kubernetes Cluster template. Rename the stage to Dev ENV and close the side pane. In the Artifacts section on the left of the screen, click the Add button, and under the Source Build pipeline, let's select AKS CI UI. Recall that our build pipeline is named AKS CI UI. Leave other fields with default values and click the Add button. To make this release automatically run when a new artifact is published from the build pipeline, let's click on the lightning icon beside the artifact. And let's toggle the continuous deployment trigger to enable it. You can specify filters, but I would rather specify my filters in each of the stages. So let's close this pane. Select the lightning icon on the dev stage. Check for artifact filter and toggle to enable it. Let's select the build pipeline alias, AKS CI UI, and then specify the branch for this release pipeline. In this case, we need this stage to run for the dev branch. Close the side pane. Let's quickly rename and save this pipeline so we don't lose our configuration so far. Click on the name and let's rename this with AKS CD UI. Click the Save button on the right. Click OK. Now let's define our task for this release pipeline. Click on the One Job, One Task link. Select the agent job. Choose Azure Pipelines as the agent selection or agent pool, and then Ubuntu latest as the agent specification. To create custom namespaces on the fly without specifying a namespace in the pipeline, we need to run some commands on the Kubernetes cluster and paste the output in Azure DevOps to establish a connection. So let's quickly do that. Click on the kubectl task, and under Kubernetes Service Connection, click the New button. Select Service Account. To retrieve the server URL of your AKS cluster, let's click the copy icon under server URL. Open your Azure portal and make sure you're in the Cloud Shell window. Once the shell window is open, ensure that you selected Bash instead of PowerShell, and let's paste the copied command. So right click and paste, then enter. Copy the output and paste in the service connection window back in Azure DevOps. So I'll highlight this, Ctrl C to copy, and back in my pipeline, replace the values here. We also need to create a service account in the cluster with a cluster admin role assigned. This way, the release pipeline using the service account can create custom namespaces if they don't exist in the cluster and also deploy the microservices. Let's head back to Azure portal and copy the kubectl create command to create a service account. Ctrl C. Starting from AKS version 1.24, secrets are not auto-generated when a service account is created. So we need to manually create a secret for this service account. Here we have a manifest of secret kind. Type is service account token. The secret account name is AKS demo-release-sp, and the related service account name is specified under annotations. So let's copy this. Ctrl C to copy and paste in your Azure CLI window. Then enter. The secret is created. And now let's create a cluster role binding command for the service account. So scroll down and copy the command. Ctrl C and paste in the Azure CLI window. Then enter. Finally, let's get a detailed YAML output for the secret to establish a connection between Azure DevOps release pipeline and the AKS cluster. So copy the last command in your exercise file, Ctrl C, and paste in the CLI window, then enter. You should have an output like this, so we need to highlight everything all the way to API version, Ctrl C to copy, and back in my Azure DevOps, I'll paste this in the secret field. Let's provide a name for this service connection, AKS demo-release-service connection. You can check the grant access permission to all pipelines and then click Save. Now that we are done with creating the service connection, let's select the connection under Kubernetes Service Connection. Click the drop-down and select AKS Demo. Head over to Commands, click the drop-down, select Apply, and then check the Use Configuration files. In the configuration file field, let's type this, $system.default working directory, close bracket, / $, release.primary artifacts as alias, close bracket, /drop/. This command means that the kubectl apply command would execute against all manifest files found in the drop folder for the appropriate branch and microservice folder. Notice we are using variables here. This is because we don't have to manually configure this field in release pipelines for other microservices. Now let's save these and run it to deploy to the AKS cluster. So at the top, click the Save button and then click OK. To create a manual deployment run, click the Create Release button at the top. Click the Create button at the bottom. And then let's click Release 1 on the green bar. Oops! The artifact conditions are not met, therefore our dev stage release failed to run. Recall that we specified dev branch as our artifact filter for this stage, but we are yet to trigger a build for the dev branch. Let's quickly do that. Navigate to Pipelines on the left side of the screen. For the AKS CI UI, click the ellipsis and then select Run Pipeline. Change the branch from main to dev and click Run. You can click the agent job to view the logs, and we'll wait for this and check the release pipeline if it's automatically triggered. The build run was successful for the dev branch. Let's navigate to Releases and check for our AKS CD UI. The pipeline should automatically trigger, so let's refresh the page. Back in our releases pipeline, we can see that for the UI release pipeline, the dev stage was automatically triggered. Let's click the stage to view the logs. Awesome, that was fast. It downloaded the artifact for this pipeline, applied the manifest file to the AKS cluster, and completed the job. Let's confirm this in the AKS cluster. So back in my Azure portal, in the Cloud Shell window, I'll run kubectl get all and specify the namespace. Awesome. The output shows all related resources for the post-up UI microservice. First, we have the UI pod, which runs our container image that was pulled from the Azure Container Registry. Then we have the UI service, which exposes traffic to the UI pod. There is also the deployment used to ensure that our pods are at the desired state as defined in the deployment object. And we have replica set list. There is one resource we haven't seen in this output, and that's the ingress resource. To view that, let's run the kubectl get ingress, specify the namespace, then enter. All right. Ideally, you should be able to browse the host on your browser, but there is a little coupling between the UI and users microservice. So reaching this site is not possible at this time, and we'll try it once the rest of the microservices are deployed. Notice the IP in the address column. That's the Azure Application Gateway IP and would remain the same for other services exposed via the gateway. All right, automated release pipeline is working. Yay! Now let's quickly create a task template for our release pipeline so it becomes faster to create for similar microservices and stages. Back in the Azure DevOps site, click on Releases. For the AKS CD UI, click the Edit button. Click the One Job, One Task link in the dev stage. Right-click the kubectl apply task and select Create Task Group. Let's name this template AKS CD Tasks Template. Click the Create button. The task group is automatically selected for the pipeline, so simply click the Save button at the top and then click OK. Let's create the test and production stage for the UI microservice. To easily do that, click on the Pipeline tab at the top. Place your mouse pointer over the dev environment stage and click the Clone button. Just as defined for the dev environment, we want the test stage to be triggered only by artifacts from a test branch. So click on the lightning icon, change the trigger to after release, and then enable artifact filters. Click the Add button and select the build pipeline alias. Let's select the build branch for this, which will be test. Let's close this. Let's rename the stage from copy of dev env to test env. Close the pane. To create a production stage, clone any of the stage. For me, I'll clone the dev environment stage. Click the lightning icon, select after release trigger, and then enable the artifact filter. Click the Add button and select the main branch. Let's close this pane. Let's rename this to prod stage and close the pane. In order to enable pre-deployment approvals to the production stage, back on the prod environment stage, click the lightning icon and then scroll down and enable pre-deployment approvals. You can search for your name since this is a single person's project, and then close this pane. Once we are done with the setup, let's click the Save button and click OK to save. With this setup, changes to the dev, test, or main branch would automatically trigger a deployment to the respective environment as long as the conditions are met. Now that we have a template for our release pipeline, as a challenge, attempt to create release pipelines for all the backend services. It's time to configure release pipelines for our backend services. In your Azure DevOps project for this course, on the left pane, navigate to Pipelines and click the Releases option. Click the New button drop-down and select New Release Pipeline. Let's click on Empty Job and rename this stage to dev-env. Close the stage. Let's select an artifact for this release pipeline. So click on Add an artifact. Under the source, let's select for Comments Microservice. Click the Add button. We need to enable continuous deployment, so click on the lightning icon beside artifacts and toggle the continuous deployment trigger, then close this. Now let's specify a branch filter for our dev environment. Click the lightning icon for the dev stage. Enable the artifact filters. Click the Add button and select the alias. Then specify the branch. Click the Select Branch option and select Dev Branch. Let's close this pane. Let's configure the tags for this dev stage. Click the One Job, Zero Tags link and select Agent Job. Let's change the agent pool to Azure Pipelines, and agent specification should be Ubuntu latest. Beside the agent job, click the Add button and recall that we've created a template for our release pipeline and it's named AKS CD tags template. Click the Add button for this template. Let's select the task group and see if we have anything to configure. There's nothing to configure because we've used variables to define the original task. So this means that we can always plug in this task template to the multiple microservices stage we need to define. Let's rename the pipeline from new release pipeline to AKS-CD-comments. Click the Save button on the top right and then click OK. Now let's clone the dev stage for our test and prod stages of comments microservice. Click the Pipeline tab at the top and place the mouse pointer over Dev Environment stage, then click the Clone button. click the lightning icon, and let's select after release trigger, enable artifact filters, and click the add button. Then select AKS CI comments alias, and let's select the branch for test. Close this pane, click on the stage, and let's rename this to test env. Let's close this pane. Now to create the production stage, clone any of the stages. Click the lightning icon of the clone stage and select after release trigger. Enable the artifact filter and click the add button. Select the comments alias, and let's select the main branch for this stage. To enable pre-deployment approval for the comments microservice to the production environment, let's scroll down and enable pre-deployment approval, and then search for your name, and then close the pane. Let's rename this stage and call it prod env. Then close this. Now let's save the pipeline. Click the save button at the top and click OK. We are done with defining the pipelines for comments microservice. You see how simple and faster this was? Because we are using a task template to define the release pipeline. Let's quickly create a release to be certain that this works. Recall that our build pipeline for comments only ran for the main branch. So we have to run a manual build for the dev branch. Head over to pipelines and search for comments, then click the ellipsis and click run pipeline. Change the branch from main to dev, then click the run button. You can click the agent job to view the logs. Let's wait for this to complete, then check our releases to see if it's automatically triggered. The build for the dev stage is completed. Let's head back to releases. Select the comments release pipeline, and we find that deployment is automatically triggered and should be completed for the dev environment. Awesome. Let's confirm that in our AKS cluster. Back in my Azure portal, in the Cloud Shell window, I'll run kubectl get all and specify the namespace. Enter. Now note that our comments pod is showing an error, create container config error, and failing to start the container. Let's quickly investigate this to know the problem. First, highlight and copy the pod name. Ctrl C to copy. And let's run kubectl describe, paste the pod, and then specify the namespace. Enter. At the event section, we see that the image was pulled successfully, but an error occurred related to JWT secret. Recall that each backend microservice requires an env variable named JWT secret defined for the app to start up successfully. To fix this, let's create a secret called JWT secret. This kubectl command will create a generic secret, JWT secret, from literal, and the JWT key would have some phrase, which is some random key. It can be anything, any value you would like. Let's press enter to execute. Now the secret is created. Let's run the kubectl get pod. Specify the namespace. And we can see that our comments pod is showing running status now. If we should do this again, it should reflect that one pod is ready. Awesome. The error is gone as the secret is now available in the cluster in the dev namespace. When you deploy to test and production namespaces, you have to run the kubectl create secret command and ensure the passphrase is different for each environment if you'd like. For the rest of the microservices, that is the post up, post, and users, simply repeat the same steps from the beginning of this video and replace the comment keyword or artifact with the appropriate microservice you are defining the pipeline for. Remember that to simulate an automated continuous delivery to the dev stage, you have to just one time manually run the related build artifact for the dev branch. Now that we understand how to create release pipeline using task group template, let's quickly create release pipelines for the rest of the microservices. To do that, on the releases page, click the new button and select new release pipeline. Select start with an empty job and let's name the stage dev-env. Close this. Select an artifact. Under the source drop-down, let's select post up. Click the add button and let's enable continuous deployment trigger. Click the lightning icon and enable continuous deployment trigger. Let's close this pane. Now let's enable artifact filter for our dev stage. So click the pre-deployment conditions icon and toggle the artifact filter to enable it. Then click the add button. Select the post up alias. And for the build branch, let's select dev. Close this. Let's save this pipeline. Rename this to AKS-CD-postup. Then click the save button on the right and click OK. Click the one job zero task link and select the agent job. Let's change the agent pool to Azure Pipelines, and the agent specification should be Ubuntu latest. Now click the add button beside the agent job and click the add button for the continuous deployment task template. If you select the template, you'll find that there is really nothing to configure in here. So we can save this and click OK. Let's go back to the pipelines page and clone this stage to create the test stage. Click the pre-deployment conditions icon and change this to after release trigger. Enable artifact filters and click the add button. Then select post up alias. For this stage, we would select the test branch and then close this pane. Let's rename the stage from copy of dev to test env. Then close the pane. Let's repeat the same process for the production branch. Click the clone button. Click the pre-deployment conditions or the lightning icon and select after release trigger. Enable artifact filters and click the add button. Select post up alias, and for this stage we would select the main branch. If you would like to enable pre-deployment approvals, toggle to enable and then search for your name and select that. Once you're done, let's close this and then click the save button. Now recall that we need to trigger a manual build for the dev branch of our post up microservice. So head over to pipelines. And for post up, I'll click on the ellipsis and select run pipeline. For the branch, change this to dev and then click the run button. You can click the agent job to check out the logs, but let's quickly create release pipeline for the rest of the microservices. So open your releases page and click the new drop-down, then select new release pipeline. Select an empty job and let's call this dev env. Close this pane. Let's select the artifact. Under source, select post and click the add button. To enable continuous deployment trigger, click the lightning icon and enable continuous deployment trigger. Let's close this. Let's enable artifact filter for the dev stage. So click the pre-deployment conditions for dev stage. Enable artifact filter. Click the add button and select post alias. Then select the dev branch. Let's close this and rename the stage to AKS CD post. You can save this so we don't lose our configuration and click OK. Click the one job zero task and let's check the agent job pane and change from hosted Windows to Azure pipelines and select Ubuntu latest as the agent specification. Click the add button beside agent job and click the add button for the AKS CD task template. Let's save this and head back to pipeline to create for test and prod stage. Place your mouse over the dev stage and click the clone button. Click the pre-deployment conditions, select after release trigger, enable artifact filter and click the add button, then select post. Let's select the test branch for this stage, then close this. Rename the stage from copy to test stage. Close this and let's click on the clone button to create the production stage. Click the pre-deployment conditions, select after release trigger, enable artifact filter and click the add button, then select post. Let's select the main branch and close this. If you'd like to set pre-deployment approval, you can go ahead and do that, but I'll simply just rename this clone stage to prod env. Close this and click the save button, then click OK. Let's quickly trigger the build run for the post microservice. So back in pipelines, I'll click on the ellipsis for posts and select run pipeline. Change the branch from main to dev and click the run button. You can decide to view the logs by clicking the agent job, but let's go ahead and create the release for the other microservices. So go back to releases and you can see that the post hub has successfully deployed, which we created earlier. Once the run for the dev branch for post microservice has completed, then the pipeline would trigger automatically. Let's create a release for the users microservice. That should be the last microservice. So click the new drop-down and select new release pipeline. Select an empty job template and rename the stage to dev-env. Close this. Let's select an artifact. Click on add an artifact. And under source, select users. Click the add button. Let's enable continuous deployment trigger. So click the lightning icon for artifact and toggle to enable CD trigger. Close this. Let's enable branch filter. Select the pre-deployment conditions for dev stage and enable artifact filters. Click the add button and select users. Then select the dev branch for this dev stage. Let's close this pane. Let's rename the pipeline so we don't lose our configuration. AKS CD users, and then click the Save button and click OK. Click on the One Job Zero Task link and select Agent Job. Change the agent pool to Azure Pipelines and the agent specification to Ubuntu latest. Now click the Add button beside Agent Job, and for the template we need AKS CD task template, click the Add button, and you don't need to configure anything for this template. Click the Save button and click OK. Let's go to pipeline page to create for test and production stage. Place your mouse on the dev stage and click the clone button. Click the pre-deployment conditions. Select after release trigger and artifact filters, then click the Add button. Select the user's alias, and for this test stage, we will select the test branch. You can close this, and let's rename the stage from copy to test environment. You can close this. Place your mouse over the test stage and click the clone button. Let's select the artifact filter. First, select after release trigger and then enable artifact filters. Click the Add button, select user's alias, and let's select the main branch. If you'd like to set up pre-deployment approval, please go ahead and do that. I would simply just go ahead and rename this stage to prod stage. Once you're done, close this and save the pipeline. Now for the continuous deployment to work for this release pipeline, we need to manually run the build pipeline for users microservice. So head over to Pipelines, and for users pipeline, click the ellipsis and click Run Pipeline. Change the branch from main to dev and click the Run button. You can check out the logs to see how the tasks are executed, but let's go to releases and check for the previous release pipeline we set up, which is post. And we can see that the stage was automatically triggered and deployed to the AKS cluster. So this is how to set up your release pipeline using a task group template so that you can easily plug it into other release pipeline you build which are similar to the original task. I hope you were able to complete the configuration of the release pipeline for the rest of the microservices and successfully deployed all to the AKS cluster. In your Azure CLI window, let's run kubectl get ports. Specify the namespace. You should see ports for comments, post hub, post, UI, and users microservices, including the MongoDB and NATS event bus ports. Let's quickly retrieve the URL for our application and browse it. To do that, let's run kubectl get ingress and specify the namespace. Highlight the value under the host column. Then you can right click if you're using Chrome and go to the URL. Yes, the site is up and running. This is awesome. So here is our application composed of the post, post hub, comments, UI, and users microservices. And with this approach, if a single microservice crashes, for example, the comments or post microservice, users can still see posts or comments created before they crash. but they can't see new posts or comments till the crashed microservice is restored. You now see how multiple microservices making up a single application can be deployed and your app becomes highly available and fault tolerant. Awesome. Let's quickly test the features in the app. So click on the register button and sign up with an email address, a valid email. Click the sign up button. Let's click the create post button at the top. Type whatever you'd like. This is a new application. Then click submit. Now you can see that the post is created. These posts are populated by the PostUp microservice and PostUp Mongo database. When a post or comment is created, post or comment microservice would publish an event to the event bus, which is our NAT server. PostUp microservice has subscribed to post or comment created events and would store the data from such event into its PostUp Mongo database, which is then displayed via the UI microservice to your browser. Let's quickly create a comment on this post. Click the post to open, and then you can share your thoughts here. This is a microservice-based application. Click submit. Let's create another comment. Click submit. Now you can try to delete a comment. Let's delete the first comment. And that worked. So our application is fully functional and can be available to testers in your organization. Let's simulate a fault in the comments microservice by deleting the comments deployment. So head over to your Cloud Shell in Azure portal and let's run kubectl get deployments and specify the namespace. To delete the comments deployment, you can run kubectl delete deployment. And then we have comments-dev, then specify the namespace. Let's run kubectl get deployments again to be sure that that's deleted. And we don't have comments-dev anymore. Back in my browser, let's open Developers Tool. So click on the ellipses at the top right of your Chrome browser. Select More Tools, and then click Developer Tools. Make sure you're in the Network tab. And let's try to create a comment again. And then click Submit. If you click the item in the Network tab, you will see we have a status code of 502, which in simple term means that there is no response from the comments microservice. Well, that's because we deleted it to simulate a downtime of our comments microservice. Let's try to create a post. So go to create a post link and let's title this a post while comment microservices down, and then submit. Awesome. This was successful despite the fact that our comments microservice is currently down. Now let's try to sign out and sign in again and see if that works. So I'll click the logout and then click the sign in here link. Provide my credentials and click sign in. And that works too, even when our comments feature isn't functional at the moment. This demonstrates how adopting a microservice approach for your software development can make your application reliable and always available to users. If this was a monolithic application, the whole site would be down and unavailable to users, probably due to a bug causing the application to crash. If you would like to redeploy your comment microservice, head back to the Azure DevOps portal and select Comment Microservice Release Pipeline, and then click the Create Release button. Let's select the dev stage and click Create. This will redeploy the Comment microservice, and you can go back to the application page and try to create a comment to see that it works.